Hello and welcome to this video on DevSecOps. So we're going to be talking about security inside of our pipeline, inside of our DevOps environment, and how we can build on the ideas of application security as we discussed in the first video, hopefully the one that you've watched before this, about different types of application security vulnerabilities and the OWASP, so that you have a better idea of kind of some of the things that we're trying to overcome when it comes to building secure applications. So what we're going to talk about in this video is really what is DevSecOps, how it differs from treating security as a final checkpoint and kind of baking it into the process. We're going to talk about where security fits in a CI/CD pipeline, how to add a dependency vulnerability scan step to our GitHub Actions workflow, understand what the SAST is, more acronyms, and how it relates to the tools already in use, and know what our scan output means. So we can do these dependency vulnerability scans, know what the scan output means, and what actions to take. So let's start at the beginning. What DevSecOps is. Traditional software development kind of thought of security as something you did at the end of the finished product. You would take that finished product and you would hand it to the security team and wait for a report. And this doesn't work at modern development speeds, or really we have such a large kind of threat landscape now, we can't wait until the application is finished to think about security. So DevSecOps shifts security left. Remember, we talked about moving things left, integrating it into every phase of development, including our continuous integration pipeline. Dev builds it, Sec secures it, Ops deploys it. And so all three things happen concurrently rather than sequentially. The most actionable thing that you can do or that you can add to your pipeline right now is dependency vulnerability scanning. And it requires no code changes, but it will catch real documented vulnerabilities automatically. So thinking about shifting security left, our traditional model would think about we plan, we gather information, what is the problem, what is the business logic, we design, then we develop, then we test, then we deploy, and then there's a security review in there somewhere, and then we release. So security happens at the end, often as like a gate to release, but by that point, fixing problems and vulnerabilities is expensive. The code is already written, it's already tested around an insecure pattern, and we have to undo basically everything that we have done if we find a security issue and rewrite it, instead of trying to think about how we could have caught that earlier and built more secure kind of from the ground up. So the DevSecOps model builds threat modeling and thinking about those vulnerabilities into the plan, bakes a security review into the design process. So before we even write any code, does that SAST, that's a static application security testing, plus some pre-commit testing into our development phase. We have dependency scans, and we're looking for, secret scans, accidentally checking those things into our repo during that CI/CD step. And then DAST, that's a dynamic application security test, added into a pen or penetration test at the deployment stage. So security checks at every stage. It's caught earlier, it's cheaper to fix, and we can really limit our security exposure and some of the application threats that might have gotten baked in under the earlier model. So we have some new acronyms to learn if you're not coming from a place of application security. So SAST, that's our static application security testing. This is where we analyze source code without running it to find security vulnerabilities. And depending on your environment, you are probably already using a form of this. So Roslyn analyzers, Pylint, it checks the code statically, but dedicated SAST tools go deeper. They're going to check for injection patterns, hard-coded secrets, insecure cryptography usage. So it's going to help find those problems, not the runtime issues, but literally code patterns that we need to correct. Then our dynamic application security testing. This is what's going to run the application. It's going to send crafted inputs. It's going to observe responses. Think of it like an automated attacker. It's used against deployed applications, and it does require a running server to target, but it's going to find these threats and surface them up so you can fix them before a bad actor does. And then SCA, this is a software composition analysis. It's going to scan your dependencies for known vulnerabilities. So this is what like pip audit and .NET list package do. And it is going to be a very immediate tool and practical for your pipeline in surfacing up some things that you can immediately fix. So some of these things, they're going to get kind of out of scope of what we want to talk about, right? I want you to know about these types of security testing. But in this kind of application course, we're really just going to look at the software composition analysis, dependency scanning, and make sure that we know how to implement those. But knowing about the other types and, of course, digging in deeper into application security and getting more into maybe a cybersecurity mindset is always valuable. The other thing I want to talk about here is secret scanning. So we want to make sure that we're never committing credentials and really before we talk about the pipeline, a secret in this context is any credential that shouldn't be in source code. So API keys, usernames, passwords, right? Database passwords, private tokens, AWS credentials, those kinds of things. And once you have maybe accidentally committed a secret, even if you delete it in the next commit, it's going to be in the history. So anyone with repo access, so if this is a public GitHub repo, anyone can see that now or in the future. They can find it. Now, GitHub does have built-in secret scanning. GitHub has basically a bot that automatically scans public repos and private repos on certain plans for over 200 types of secrets and will alert you if it finds one. So especially students, if you're new, of course, we never commit API keys, passwords, tokens. We want to use environment variables, .env files, and make sure that your .env is not getting checked in, right? It's added to your gitignore file. And if this happens, what you have to do is rotate the credential or the key. You can't just go delete it. Of course, it's going to stay in the repo history. There's not much you can do other than maybe dumping the entire repo, which is not usually a solution that you can follow through with. And even then, there are bots, not GitHub bots, but they're bots that live on GitHub, that crawl public repos looking for exposed API keys, and then they will log those or try to use them. So just assume it's already compromised. If you accidentally commit a secret, you have to rotate that credential immediately, assume it's burned, and then move on and try to learn from that. So let's talk about how we run that dependency scan in our continuous integration pipeline. Starting with Python, pip audit maintained in the Python Packaging Authority is the official recommendation for Python dependency scanning. It's going to check installed packages against the Python Packaging Advisory Database, and it's going to surface up if there are any problems that we need to address. So here you can see an example of adding this into our lint.yaml file. It's going to run in parallel with our lint and test that we've set up previously, and that is going to exit with a code 1, when vulnerabilities are found, which is going to fail our CI pipeline. And we don't really have to do anything extra. It just gates it, and we will have to fix whatever is triggering that exit code 1 and make sure that our pip audit passes. For those of you on the C# track, this is built into the .NET SDK, so no additional package needed. Here you can see adding this into our YAML file. So .NET list package with the vulnerable flag is always going to exit 0. And we are going to have to add this into our script, and we can echo out, something like you can see here, vulnerable packages found, and exit with a 1. That way the script captures and checks for the vulnerability text, and if exits 1 is found, it's going to fail the pipeline. So it does take just a little extra step on the C# side. The shell script captures the output and checks for that vulnerability message. It's not kind of built in like it is with pip audit. It doesn't exit with a non-zero code when vulnerabilities are found. It's going to always exit 0. So we have to kind of force the behavior that we want, but this is what you'll find in most .NET scenarios to check for that dependency scan. So what we see when we run these, if everything is passing, we get, all the green checks. The merge pull request would become available, provided any other checks that we had in place, like doing a human review, had also already been fulfilled. If the scan finds a vulnerability, the merge is going to be blocked, and we're going to see that one vulnerability found, or we're going to see that message on the .NET side. And the action to take is almost always going to be upgrade the package. So if you run into a situation where you can't upgrade immediately, you could probably document that as a known vulnerability in a GitHub issue, assess whether the vulnerable code path is actually reachable in your application. So what is the exploit that is causing this to come up as a vulnerability? Are you actually susceptible to that? Plan an upgrade in the next sprint. We really can't ignore it, right? A known unaddressed vulnerability in our CI scanned pipeline is a risk that you're explicitly accepting. And that can be fine temporarily, but it has to be tracked and resolved. And so if we are committing ourselves to code quality, or the industry and environment that you work in has certain benchmarks that all of our merge requests have to meet, then a plan will have to be made to upgrade this package, kind of no matter what. So let's get into some key takeaways. So DevSecOps, this might be a brand new idea, of course, a lot of new terminology, but it integrates security into every phase of development rather than treating it as a final gate. And we take that idea of shifting left down that kind of set of steps from, planning through to release to put security more in the forefront of the minds as you go instead of it being just at the end. We talked about 3 types of security testing: static code, dynamic code, and our dependency scanning, and then looked at some examples on how to do this with your various either Python or C# related environments. We do want the scans to run as separate parallel jobs. Both jobs are going to have to pass before merging, but always remember, when a vulnerability is found, we're just going to upgrade the package, rescan, and push. And if you can't, you'll have to create a plan using GitHub issues, documentation on what is going to happen next so that you can plan for the upgrade that needs to happen for that package. The hardest ones of these to solve, I think, are when we have maybe a smaller third-party package that the developer isn't really motivated to update, and then we're just kind of stuck either needing to find a replacement package and get away from the one where the developer maybe isn't going to provide a ready solution, or we have to just wait it out. Removing the dependency scan gate from your CI pipeline would be a really drastic measure in order to push a release, because you're pushing vulnerable code. So that would definitely be something that has to have a larger conversation inside of whichever organization with your leadership team to see if that is even feasible. But It has been known to happen with smaller teams, maybe one-man band type package maintainers, that maybe a particular CVE is just not a high priority for them, but it's causing your CI to fail. So, as always, I hope you have enjoyed this video and learned some new things about DevSecOps. Let me know if you have any questions, and I'll see you in the next one.